Okay, let me read the question now. Solution by graph sketching is not accepted. Two particles A and B move along a straight line. The velocity of particle A, VA meter per second, is given by VA is equals to 24t minus 4t square minus 20, while the velocity of particle B, VB meter per second, is given by VB equals to 24t minus 25, such that t is time in seconds after both particles passing fixed point O. Okay, so this is the oral question 12. Okay, so from here we are required to calculate the maximum velocity in meter per second of particle A. So this is for the question part A. Okay, for the question B part 1, they ask us to calculate the time in seconds when particle A and particle B meet. Okay, for the part 2, they ask us to calculate the total distance in meter traveled by particle A in the first 5 seconds. Okay, so this is the oral question 12. Okay, so without further delay, let us begin our discussion with the question 12 part A in a count of 5, 4, 3, 2, 1. Let us begin our discussion for the part A, where we require to calculate the maximum velocity in meter per second of particle A. So in order for us to find the maximum velocity of particle A, so what we need to do is we need to find the turning point of velocity of particle A. So in order to find the turning point of velocity of particle A, so what we need to do is we need to differentiate the velocity of particle A with respect to time, and we are required to set it equals to 0. Okay, so from here, let me write the explanation here. To find maximum velocity of particle A, so from here you differentiate velocity A with respect to time, and then you set it equals to 0. Okay, so this concept is also known as the turning point. Okay, which you have learned this in your differentiation chapter. Okay, where turning point is used to calculate whether your point is either minimum or maximum. Okay, so from here we differentiate velocity A with respect to time. So from here you differentiate velocity A. So from here you get is 24 minus with 8t, okay, you get equals to 0. Okay, so from here 8t is equals to 24. Okay, 8t is equals to 24. So t, you calculate this, you get t is equals to 3 seconds. Okay, so this is basically your step 1. Okay, so once you get the t is equals to 3 seconds, so you substitute back into the velocity A equation. So from here, when t is equals to 3 seconds, okay, given that your velocity A is equals to 24t minus 4t square minus 20. Okay, so from here velocity A is equals to 24 times with 3 minus with 4 times with 3 square minus with 20. Okay, you calculate this, you should get your velocity A is equals to, okay, so 24 times with 3 you get is 72. Okay, 72 you minus with 36, you get is 36. So 36 minus with 20 you get is 16. So from here you get your velocity A is actually 16 meter per second. Okay, so this is your answer for question part A. So let me underline the solution. Oops. Okay, so we have done our discussion for the question 12 part A. So let us proceed our discussion for the question 12 part B now. Let us continue our discussion for the part B by beginning with the part 1, where we are required to calculate the time in seconds when particle A and particle B meets. Okay, so based on this statement, okay, they ask us to calculate when particle A and particle B meets. Okay, when this scenario occurs, okay, so from here we can conclude that our displacement of particle A is actually same as the displacement of particle B. Okay, so from the question we need to come up with the equation, and once we get the equation, so from there we can proceed our working and get the solution. Okay, so from here read the question carefully, guys. Okay, so let me highlight in the explanation here. Okay, so from here they mentioned that when particle A and particle B meet, and one more thing we need to take a note that both particle is actually pass through point O. Okay, pass through point O. Okay, so this point O means that when your time equals to 0, your displacement is actually equals to 0. That is the meaning of the point O in this case, guys. Okay, so from here we can come up with an equation where your displacement of particle A is equals to displacement of particle B. Okay, now we have a problem. The question only gave us the velocity of particle A and velocity of particle B. So how are we going to find the displacement? Okay, don't worry, guys, it's actually very simple. So the only thing you need to do is you need to integrate the velocity equation. Okay, so once you integrate the velocity equation, so from here you can get the displacement. Okay, so quite straightforward. Okay, so from here we integrate the velocity of particle A on our left hand side. So from here we integrate for the particle A. So from here you get 12t square. Okay, 12t square minus 4 over 3t cube minus 20t, okay, equals to 12t square minus with 25t. Okay, so this is based on the integration of velocity for particle B, guys. Okay, for the particle B is actually 12t square minus 25t after we integrate the velocity of particle B, where it is equal to 24t minus 25. So 24t minus 25, so you integrate this, you get 12t square minus 25t. Okay, so both sides of equation you have 12t square and 12t square, so you can easily simplify them. Okay, cancel them out. Okay, so from here you group the like terms. Okay, so what you do, okay, so from here this negative 25 from the right hand side you move it over to the left hand side, so it will become positive 25. Okay, so from here you calculate, you get 5t. How you get 5t? 25 minus 25t minus with 20t, so that's how you get 5t, and then minus with 4 over 3t cube equals to 0. Okay, so far so good. So from here let us continue our working. Okay, so from here what we do, you factor out the t. Okay, so from here you get 5 minus with 4 over 3 t square equals to 0. Okay, so from here it will split up into two possible answer. Okay, you'll get either t equals to 0. Okay, and here will be the second equation where 5 minus 4 over 3 t square is equals to 0. Okay, so from here 4 over 3 t square is actually equals to 5. Okay, you calculate this. To find t square, what you do, 3 times with 5, so from here you get 15, and the 15 you divide with 4, so from here you get t square equals to 15 over 4. So to get t, what you do, you square root 15 over 4. So from here you get your t approximately 1.936 second. Okay, so here you will have two possible answer. Is either t equals to 0 or t is approximately 1.936 second. But take a look at the question carefully. So the question says that both particles meets. Okay, both particle meets. Okay, and one more thing I would like to highlight here is the both particle is actually passes through point O, which means that when your time is actually equals to 0, your displacement is actually equals to 0. Okay, so time is equals to 0, it's indicating the initial point. So t equals to 0 can never become the answer. So in this case, our answer will be t is approximately 1.936 second. So which means that at t is approximately 1.936 second, your particle A and particle B will meet in the same displacement, where your particle A and particle B will have the same amount of displacement. Okay, t equals to 0, of course it makes sense because both particle is starting through the initial point O, where your particle displacement equals to 0 when your time equals to 0. Okay, so this will be the accurate answer. So in this case, because your particle is meeting again. Okay, when your particle meets, so that's where your particle meets at your time equals to 1.936 second, where your displacement of particle A is actually equals to displacement of particle B. Okay, so let me underline the solution. So this will be your answer. Not t equals to 0 guys, but t equals to 1.936 second. Okay, we have done our discussion for the question B part 1. Let us proceed our discussion for the question B part 2 now. Let us continue our discussion for the question 12b, where we are required to calculate the total distance in meter traveled by particle A in the first 5 seconds. Okay, so let me remind you that solution by graph sketching is not accepted, so which means that you need to solve this question using the integration method. Okay, so from here the first step what we need to do is we need to find the main intercepts, okay, which is the x-intercept, y-intercept, and then the maximum point. Okay, the maximum point we have already calculated, which in the earlier of the question, where t equals to 3 seconds, you get your velocity A equals to 16 meter per second. Okay, so let us write it down first. Okay, so max point okay, when t equals to 3 seconds, VA equals to 16 meter per second. Okay, this is one of the point. Okay, so the second point that we can find is the y-intercept. Okay, please take note, you need to use the equation of velocity of particle A, not particle B. Okay, so y-intercept. So from here, how to find the y-intercept? You set your x equals to 0. Okay, when x equals to 0, so from here you get your velocity of particle A is equals to negative 20 meter per second. Okay, so you already got the max point, you already got the y-intercept. Another most important point is the x-intercept. Okay, x-intercept, you need to set your y equals to 0. So from here you set your equation of particle A, velocity of particle A. Okay, so from here 24t minus 4t square minus 20 equals to 0. Okay, velocity of particle A equals to 0. So let us continue our working. Okay, so from here you alter this equation. Okay, so from here you get is 4t square minus 24t plus with 20 equals to 0. So you factor out the 4. So from here you get is t square minus 6t plus with 5 equals to 0. Okay, so you factor this further. So from here you get t minus 1. Okay, and then t minus 5 equals to 0. So from here you get 2 x-intercept where your t is equals to 1 second and t equals to 5 seconds. Okay, so far so good. Okay, let me write the summary of this step 1. So step 1, identify max or minimum point, x-intercept, or should I better write y-intercept? Y-intercept, okay, and then x-intercept. Okay, and number 4 is actually range. Okay, range in this case, since the question asks us to find the first 5 seconds and we already get our x-intercept correctly fall and the 5 seconds, so technically we don't really need to find the range. Okay, otherwise let's say for example your x-intercept falls such that your t equals to 1 and t equals to 3 seconds. So that means that you need to find the value of velocity A when time equals to 5 seconds. But in this case, since your x-intercept fall exactly on t equals to 5 seconds, so there's no need to calculate the range. Okay, so range is actually optional. Okay, well, it depends on the question, guys. You should have a 4 steps. Okay, maximum, minimum point, y-intercept, x-intercept, and the last one is actually low and high range. Okay, so once you fulfill the range ready, okay, now you can do the basic sketch. Okay, by the way, I've already done the basic sketch for you, so let me just copy paste this. Okay, now you can ask me, so you said solution by graph sketching is not accepted, so why are you doing the graph sketching over here? Actually, this graph sketching is just for you to visualize how you're going to perform the integration. Okay, so there is a difference. So in this case, since we need to calculate the total distance in meter traveled by particle A in the first 5 seconds, so how are you going to calculate the integration? Okay, there are 2 segments over here. This is segment 1. Okay, this is segment 1 and this is segment 2. Okay, the modulus of segment 1 you plus with the area of segment 2, so you combine them together, you will get the distance traveled in the first 5 seconds. Okay, so this is the idea on how we're going to solve the question. Okay, so let us proceed our calculation now. Okay, so from here our integration S is equals to, okay, the segment 1, which involves the modulus, okay, lower limit, upper limit 1 and lower limit 0. Okay, so from here 24t minus 4t square minus 20, okay, in a bracket, dt close modulus plus with the second segment, upper limit 1 and the lower limit 1, 24t minus 4t square minus 20 close bracket dt. Okay, so from here you perform the integration for the both equation. So from here you get your s, okay, is equals to, okay, you still have the modulus symbol. Okay, you perform the integration, you get 12t square minus 4 over 3 t to the power of 3 minus 20 t, okay, 1 0 plus with 12t square minus 4 over 3 t cube minus 20 t. Okay, 5 1. Okay, upper limit 5 and lower limit 1. Okay, so we have already performed the integration. So let us perform the integration one by one. Okay, so let us solve this particular set of integration where you have the upper limit of 1 and lower limit of 0. So from here s is equals to, okay, modulus 12 1 square minus 4 over 3 1 cube minus 20 times it 1 close bracket minus 12 0 square minus 4 over 3 0 cube minus 20 times 0, okay, close bracket, close modulus. Okay, we just solved the first set of integration. Okay, we have already included the upper limit 1 and lower limit 0. Let us proceed on the second one. Plus, okay, see here the modulus here is for your reference. Okay, modulus, okay, plus 12 5 square minus 4 over 3 5 to the power of 3 minus 20 times with 5, okay, close square bracket minus with, okay, let us continue. Twelve times with 1 square minus with 4 over 3 1 cube minus with 20 times with 1 close square bracket. Okay, you calculate this. So from here you get is 28 over 3. Okay, for the first set of the one involving the modulus 1, so you calculate this, you get 28 over 3. Okay, and the second one, which involves the upper limit of 1 and lower limit of 1, I mean upper limit of 5 and lower limit of 1, so sorry guys. So from here you get 128 over 3. Okay, so 128 plus 28, so from here you get 156 over 3. So you calculate this, you should get your answer is 52 meter. Okay, so 52 meter is your answer. Okay, which means that for the first 5 seconds, your particle A has travelled in a distance of 52 meter. Okay, this is your answer for the question 12B part 2. Okay, so I hope you find this video useful. If you like this video, please make sure that you give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming Math tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.